Hello, geometry students. Welcome back to Chapter 10. Chapter 10, remember, is all about circles. We've been talking about inscribed angles, central angles, all sorts of wonderful and fun things. And our last section was all about, tangents. Well, now we're going to add on, this section is called secants, tangents, and angle measures. So we're talking about angles in this. So please keep in mind that when we look at these, all of our answers will be angle measures. That's a big deal, something to keep in mind when you are going to do your problems. So everything will be angle measures. There's three situations that we can happen, but first let's talk about secants, and I'm going to make sure I point out as we do the practice problem which one of the three situations and then what formulas we use. So a secant is similar to a chord in that it intersects a circle in exactly 2 points, but a chord had endpoints, right? It was a segment. A secant is a line, so it keeps going. So if I've got a circle, pretty good one, and I've got a line that intersects a circle in exactly 2 points, this is a secant. I could call it like secant L, or, I could name them if I wanted to. I can also name the points at which they intersect if I wanted to. So if I have two secants, sorry, my microphone's a little sketchy today. If I have two secants, those two secants can intersect, right? They not only do they intersect the circle in 2 points, but the secants themselves can intersect. So when two secants intersect, the angles formed are related to the arcs they intersect. So the way I've got this drawn, we would look at this arc right here that's being intersected, and we'd look at this arc right here that's being intersected. But I could change it up. I could make them intersect like this. So then we'd look at this piece of the arc that's being intersected and this large piece of the arc that's being intersected. Or I could have them be intersected right on the circle. So we look at the arcs that are formed. So remember, this is all about angle measures when we have secants. So the first theorem says this: if two secants intersect in the interior of a circle, then the measure of the angle formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. Hopefully everybody's got that, right? So if you look at this diagram, first of all, I've got interior bolded and italicized. Here's the first of our three situations, the secants. So I've got line AB in this diagram and line CD. Those two secants are intersecting, and the point at which they intersect right here, right there, is inside the circle. So interior is inside, so our first situation is inside. So the secants intersect inside the circle. So here's what we do. If I draw these two secants, and remember we were just talking about the arcs intercepted. So if I look at this guy right here and this guy right here, remember it's not a central angle. That point of intersection for those two secants is not on the center. So the best that I can do is I can take the measures of the arcs. It says it's half the sum of the measures of its arcs. So I'm going to say that angle 1, let's say angle 1 right here, it's kind of squished in there. The measure of the angle is half the sum of the measures of the intercepted arcs. So arc AC that I've got highlighted over here on this left side, plus, because that's sum, arc BD that I've got marked over here, and it's half the measure. So you could do half of AC plus BD, or you could do AC plus BD divide by 2. So if I were looking at angle 2 is an obtuse angle, right? You got a couple options here. If I were looking at angle 2, I could say, well, this arc AD is what's intercepted, and CB is intercepted. So I could say that angle 2 is equal to arc AD plus arc BC all over 2. However, some of you might notice a golden oldie here. If I have just figured out angle 1, and I know that CD is a line, how do 1 and 2 relate to each other? They add up to 180, right? Straight lines. So golden oldie, supplementary angles, don't forget. Supplementary angles, they add up to 180 if they form a straight line. So if it's inside, we add. I think of it, I know it's dumb. Here's my 2 secants intersecting inside. Looks like a plus sign to me. So that's how I remember that. All right. So let's do a quick example. Find the measure of angle 2 if arc BC, it's marked on there, is 30 degrees. So this guy right here, it says measure of arc AD is 20 degrees. I want to know the measure of angle 2. Well, we can use our golden oldie here. If I'm drawing the secants, notice they draw it like a chord just to throw you off balance. But if I drew a secant, I would just continue with BD. I would continue with AC. Those two guys definitely intersect inside the circle. So I'm going to do it this way. I'm going to say, well, here's the intercepted arc for angle 1. Here's the intercepted arc. Remember, those are vertical angles, right? I should have put down vertical angles as well for a golden oldie up here. Golden oldie, supplementary angles, and vertical angles. Don't forget about those. So I could say that angle 1 is equal to, because I don't know these arcs right here. I don't know that major arc DEC. I don't know that arc AB. So why don't I find angle 1? So it would be arc AD, I'm going to write it over here, plus arc BC, all divided by 2. So the measure of arc AD is 20, plus the measure of arc BC is 30, divide by 2. Probably you can figure out that pretty quick. That's 50 divided by 2, or 25 degrees. So angle 1 is 25 degrees. Its vertical angle is 25 degrees, but it asks for angle 2, right? Well, look at this. Isn't this handy? Angle 1 plus angle 2 are supplementary angles. Therefore, angle 2 has to be equal to 180 minus the 25 that we just found. So angle 2 is equal to 155 degrees. Check my math, but I'm pretty sure I got that one right. We needed to do angle 1 because we didn't have the information for angle 2. So that's a really easy shortcut. We've got smaller numbers. We don't have given information. So we can just use supplementary angles at the end. All right. Second situation that can happen is we can have a secant and a tangent intersect at the point of tangency. Then the measure of each angle formed is half the measure of its intercepted arc. So what we've got here, the point of tangency, remember, is on the circle. So here's our second situation, on the circle. So it's not technically a secant if it's outside of the circle, right? So this AD is a tangent. BC is a secant. It could keep going past B, you know, like they could draw that. They just didn't. So they intersect on the circle. So the measure of, say, arc AC, the intercepted arc, see how we're looking inside this. So this is my highlighted angle right here. So the measure of arc AC, or whatever we want to call it, is, or I guess I could call it angle ABC. I should call it ABC. I'm looking for an angle, right? Angle ABC is equal to half of its intercepted arc. So I'm going to say that's arc BC divided by 2, or 1/2 of BC if you prefer. Golden oldie happening here. It's not that old. If I knew the measure of angle ABC, could I find the measure of angle CBD? Right? Still supplementary angles. So we still have supplementary angles. Also, if I knew the arc BC, could I find the major arc CEB, the rest of that circle? You could, right? I might be asking for angle DBC, so I need to know that major arc. What do angles, or what do the angles of a circle add up to? I'll just put circle equals 360 degrees. So if I told you that arc AC was 100, we could very easily find that major arc CEB is 260. So don't forget that golden oldie. This is our second situation. If those two lines intersect on the circle, it's called a tangent and a secant because a tangent can't be a secant because it doesn't go inside. It's only got one point, whereas a secant intersects a circle in 2 points. Here's our third situation. They're very similar. If two secants, like in the very first box, a secant in the tangent in the middle box, or two tangents intersect in the exterior of a circle. So these guys are intersecting outside the circle. See how point A in all three of these examples are outside the circle. So last situation here, they can intersect outside. Then the measure of the angle formed is half the positive difference of the measures of the intercepted arcs. Notice the word difference in here. Difference tells us to do what mathematically? We subtract. That's why I pointed out in that first situation when they intersect inside the circle that it looks like a plus sign. This is subtract. So I'm looking at my intercepted arcs. This is where I have a fun time highlighting. So I'm going to take these two secants in this first situation. I'm going to highlight like a flashlight beam. My two intercepted arcs are this little tiny BC and this little bit bigger arc DE. So my angle A, remember we're always finding an angle. Angle A is equal to the difference of those two arcs. So DE minus BC, always put them into your calculator so that you've got a positive. Let me start that again. Arc DC, or arc DE minus arc BC, all divided by 2. That's how we find the angle. Now, sometimes I might give you the angle and say, tell me arc BC. So we just put an X in for that. So I want you to write it out as an equation because then it's easy to just plop things in there. Secant and a tangent, we're going to do the same thing. I'm going to highlight because I like to highlight. So if I just take that angle, these two lines, AC and AD, are intersecting outside the circle. I'm going to highlight that like a flashlight beam. So it's the same formula, it just looks a little bit different. So in this case, angle A is equal to the two arcs subtracted. So here's my arc BC. Here's my larger arc DC. So I'm going to do arc DC minus BC all over 2. Half the difference of the measures of the intercepted arcs. And last but not least, same formula. It's a subtraction. Just always remember it's subtract. So here's my flashlight beam when I look at those angles. So in this case, angle A, this little angle down here, is going to be equal to the larger arc. So major arc BDC minus the minor arc BC, because I always subtract, so I do bigger minus smaller, all divided by 2. So subtract the two arcs and divide by 2. Now there's an interesting thing here, because in that two tangent last situation, if we added those two arcs together, we'd get 360 because the tangents make up the whole circle. Remember to subtract them. All right, so let's do a quick example here. So example 2, if I'm going to find x, x is in angle C. So here's what I'm looking for. These two secants, DC and AC intersect outside the circle. C is outside where those two guys intersect, so I know I'm going to use these rules, which is subtracting. So my angle C, or X, is equal to subtract the two arcs. So if I highlight and look at my intercepted arcs, here they are, flashlight beam. So the bigger arc, 120, minus the smaller arc, 50. Divide that by 2, easy math problem, right? X equals 70 over 2, or 35 degrees. So angle C is equal to 35 degrees. There it is. All right, so got a couple more examples. Let's do a couple more problems just so you can see them. Let's see what we got here. Find the measure of angle 4. So here's my X right here, angle 4. If the measure of arc FG is 88 and the measure of arc EH is 76. Well, that's the information that I have. So if I'm going to highlight, right, that's my intercepted arc and my angle. This is my intercepted arc and my angle. So if I found angle 3, because it's in the highlighting, could I find angle 4? Of course I could, right? So angle 3, by the way, these two secants, they drew them as chords, but these two secants intersect right here. Is this inside, outside, or on the circle? That point of intersection is inside the circle, which tells me I have to add when I do my formula. So I know that it's the two intercepted arcs. So I'm going to take the 88 plus the 76. Does not matter what order you put them in. Divide that by 2. So angle 3 is going to be equal to 82, I think. But that's not my final answer, right? It asks for angle 4. If angle 3 is 82 degrees, we can easily find angle 4. Angle 4 is going to be equal to supplementary angles, so 180 minus 82. So my final answer is going to be angle 4 is equal to 98 degrees. So I couldn't directly get to angle 4, but I could indirectly by using supplementary angles. All right, how about this one? Find the measure of angle RPS. I'm going to highlight RPS. So P is the vertex, RPS. So this, whoopsie. So this whole angle right here, there's angle RPS. The measure of arc PT is 114. Got that on my diagram. The measure of arc TS is 136. So this guy's 114. This guy's 136. But my point of intersection is on the circle. I've got a secant PS and I've got a tangent QR. On the circle means that I just do the arc divided by 2, right? The intercepted arc. Well, my intercepted arc, what I'm actually looking for is this guy from P to S. That's in the highlighted area. That's in that angle that I'm looking for. So could I find arc PS? Arc PS has to be equal to the 114 plus 136. Take that answer and subtract it from 360. So what's that going to be? Something like 110. This comes out to 250. So 360 minus, so 110. Double check my math. So angle RPS, or if you prefer to put an X there, is equal to the arc that's intercepted, so 110 degrees divided by 2, so angle RPS is equal to 55. Final answer. So on the circle, we only have one arc because there's only one arc to find. If you want to highlight so you can see what arcs you're working with and what angles. So when you highlight the angle, the arc that's highlighted is the intercepted arc. How about these guys? Find X. Assume that lines that appear to be tangent are tangent. Well, we've got two secants, right? They're not even labeled, but if I look at these two secants, I definitely know that they intersect here, outside the circle. I go back and look in my notes, and outside means that I find the difference or subtract. So if I'm going to highlight things, I'm going to take where these two guys highlight, or these two guys intersect, and I'm going to do that flashlight beam like that. So this one's an interesting one because we said the angle is equal to arc minus arc all over 2, right? Well, I know my angle. That angle with the little arrow is 62 degrees, so that's got to go in that spot right there. The arc minus the arc, the bigger minus the smaller, so I'm going to do 141 minus x, all divided by 2 because that's part of the formula. I don't know about you, but I like to get rid of a fraction by multiplying by 2. Remember, when you do that, you're just left with the 141 minus x because the 2 cancels with the denominator. This comes out to 124. Don't worry about the solving. When you subtract 141, you get a negative number, right? Negative 17. But notice, when you cancel this out, you're left with a negative x. So if negative x is equal to negative 17, technically we're dividing by negative 1. So x will be equal to 17 degrees. That means that this little arc right here is 17 degrees. All right, let's do one more. It's an interesting one. So number 4, notice I've got 2 tangents. I could have drawn them. The way I know that they're tangents is that only hits the circle here, and this line only hits the circle here. So those 2 tangents, where they intersect is at point U. Point U is outside the circle, right? That's where their point of intersection is. So outside equals subtract. So I'm going to subtract my 2 arcs. So angle is equal to arc minus arc all over 2. Well, this is my angle right here. Notice another weird problem. It says that it's 5x plus 10, and that's what's got to go in the angle spot. If I were to highlight going out where those 2 tangents intersect, right, the whole circle ends up being highlighted. The angle itself is that x. So when I do arc minus arc over 2, I'm going to do the big arc. Do you know the big arc? If you're saying no, I'm going to tell you that you sneakily know the big arc because you know this little arc, right? This guy is 110. I know the smaller one goes there. If this side of the circle is 110, this side has to be 360 minus 110. So that's going to be like 250 degrees. So, not our typical problem. It's not just a quick put it into your calculator situation. I don't know about you, but we could just go ahead and do some math problem on the right hand side. 5x plus 10. 250 minus 110 is 140, divided by 2 is 70. If you didn't catch that was a math problem, you could still multiply both sides by 2, and you'd have 10x plus 20. You'd end up doing 140. You'd get the same problem. So quick 2-step equation here. I'm going to minus 10. So 5x equals 60. Divide by 5, so x equals 12. I'm not sure. Are we done with this problem? I guess so. It just said to find x, right? Or it didn't even say. If I asked you to find angle U, could you do that? Well, of course, because we just found out that x equals 12. So 5 times 12 is 60, plus another 10 is 70. So don't forget to look for those sneaky little problems, and we might have some, a little bit of extra math to do. So 3 situations. The 2 secants intersect inside the circle, which means add. On the circle, which means you just take the arc divided by 2, or outside the circle, which means you subtract your arcs and divide by 2. Everything's got to divide by 2. That is it for section 10.6. We'll do a lot of practicing and make sure everybody sees those situations, and perhaps we'll pull out some highlighters. Have a good one. I'll see you next time.